Hi, today I'm going to be showing you how to use jAmeseis to locate the epicenter of an earthquake. Recently there was a 7.3 earthquake in Russia. For reference, I'm going to be locating this earthquake on a map. And then we can go back to the data table and figure out exactly when that happened, which looked like it was 1701 Universal Time Coordinated. And then we're going to go to Manage Sources in jAmeseis. For trilateration, we are going to want 3 different sources. I would use the Iris server to retrieve your data. And looking at the map view, you can see all of these professional seismic stations. I'm going to zoom in to one near Illinois, which is the state we're located in. And here I have 3 different seismic stations recording the same earthquake from Russia. We're going to highlight data that was near the time of the earthquake occurrence and extract the data to make sure you're getting all the seismic waves, including the surface waves. Once you do that, you're going to save it as a SAC file, which stands for Seismic Analysis Code. Once you have saved your files, go to Event View, and then we're going to upload those SAC files that we downloaded from each of the 3 stations. And then here we're going to compute the distance using the P and the S waves. And this is where it takes some practice, finding out exactly where the P waves are, where the S waves are. Some data is a little bit more clear, some is a little bit more ambiguous. So I'm going to try and match the P wave up with the P curve, the S wave up with the S curve, and then these last 2 curves are Love and Rayleigh waves, which are the surface waves. And then you're going to double click to provide that line for reference as to where exactly we think each of the types of waves started. And that's going to give you that nice circle of all the points around the epicenter of the earthquake that earthquake could have occurred. Once you have estimated the P and the S curve, you can look at the map to see if it lines up with the known location of the earthquake. And if you need to, you can adjust where you think the P and the S waves started. Here you can see it's starting to match up a little bit closer to the actual epicenter. So that looks pretty good. We're going to move on to the next one. Do the same thing with the P and the S curves. And then we're going to be moving the data down. The reason we're moving it down is because the y-axis stands for degrees away from the epicenter of the earthquake. This is called the epicentral distance, and it's an angular distance from the center of the Earth. And so since Taiwan is slightly closer to Russia, the circle is actually going to be a little bit smaller, and the epicentral distance will be smaller. That also means that the time it takes for the P wave to come in and the S wave to come in is going to be shorter. So that looks pretty good. Moving on to the next one. You can zoom in. That's way too big. You can kind of tell because the surface waves, those large waves, were not matched up at all to the Love and Rayleigh waves. A little bit closer. And that looks a little better. And again, the more you do this, the easier it is to locate the P waves and the S waves. Also depends on the type of earthquake, the locations that you're using, how clear the data actually is. There are actual programs that do this for you, but for educational purposes, this gets the point across. And here, they're pretty close.